asked you too, how many of you are already working with generative AI in some form, right? Yeah, maybe a few of you. Okay, very cool. Yeah, and I actually will be also doing a survey as well. So, yeah, so again, I actually should have to tell you too, when I submitted this talk, actually I was meant to be for a workshop, and then I ended up doing it at VanCat. VanCat actually had an AI conference in the US, in Texas, like earlier this month in April. So I did that as a full day workshop, but then I realized, okay, here it's only like a 1 hour session. So I hope to be able to compress it and won't actually have time to go to, way too much details because of that. But I will be sharing with you too the GitHub repo if you're interested in looking at some of those hands-on exercises too. So it's not just like coming to a talk, but basically you can also have some follow-up if you like, right, after the session and learn about things, learn about GenAI. So, okay, so that's me. And thank you again for introducing me. So I won't spend too much time. But this is like what my agenda is. And I call it demystifying because I feel generative AI has created such a big stir, right, among everything. Seems like the whole world is turning to GenAI. And people are actually talking about AI as if AI never happened before, right? But as we all know, AI and machine learning have already been, in the works for a number of years, but somehow it wasn't being brought to the foreground. I think also because a lot of the work's been done mostly by, so to speak, a bit more privileged people. If you're working in some research or some special teams, data teams, and you're able to get to it. But now with ChatGPT that came out, generative AI is making it more accessible to a lot of people. So anyway, this is the plan. I'm just going to give a very brief background because maybe not everybody has worked with AI yet. So bear with me. I'll just have some introductory, and then I'll get into the different aspects of generative AI, especially from a developer's point of view, the kind of topics that we need to be paying attention to, right, to work with too. And then so all those things are listed there, and then some challenges. And I actually also have some lab exercises. Like I said, it was, designed for more of a full day workshop. So I have some exercises too. I hope you find it useful as well. So that's the plan. So let me start then. Real quick intro. I've already been introduced, so I won't spend a lot of time, but I kind of decided to do it in a picture. So if you want to get a hold of me, I will be sharing this slide deck too. Then you'll have access to all of my contact information, and also I have a Discord server too if you want to stay in touch and just stay connected and ask questions and connecting to my community. I want to also say I'm also Chicago Java Users Group president, and also there's another group called GenAI Collective, Chicago chapter. I'm the organizer as well. And as well as there's another AI camp, but I've spent more time on GenAI now. So that's what it is. So I'm actually also director of emerging technologies at this company called Calibri. It's based in the U.S. in the state of Ohio, Cincinnati to be specific. But I'm based in Chicago, just so you know. So we're about, if we drive, it's about 5 hours difference. It's all in the Midwest. So, okay, so that's me. So actually, before I start I'd like to do a quick survey. If you don't mind, if you want to participate in this, I just have a couple questions I'd like to ask you, right? So if you want to scan that, although I have to go and also start that survey too. If you go there now, it's not started. But let me kind of make sure. If you don't mind, I'm going to quickly start it, okay? Oh, somebody's already filling in. That's cool. So, okay, so now if you go there, you should be able to see that survey. And, okay, I want to make sure everybody got it first. Okay. I'd like to just get an understanding of my audience too, so if you don't mind. And again, because this was supposed to be a workshop, so that's why I decided to still do this survey. So, okay, let me go there. Okay, thank you very much. Okay, so you can see everybody is already responding back. But so there are actually more folks talking about 37. This is highest. It says, I'm a developer with some experience in GenAI. So that seems to be the case. And then I'm a GenAI user, like, for example, like ChatGPT. You're more of a user. And then there's also the third one is I'm a developer with no prior experience in GenAI. So that's also maybe about a third or a quarter of you. And then they're learning about GenAI. And then also you are curious, and then also a developer with a lot of experience in GenAI. So that's very cool too. There are three of you. So thank you very much. And let me go to the next question. And I just like to get an understanding the programming languages you are familiar with. Okay. So mostly JVM and Java. Yeah, it is very true. I think that here the Developer Summit is mostly started off more as for Java developers, right? So yeah, as we can see, most of you are in fact JVM developers. So very cool. Yeah, and then Python. Yeah, and then I'm assuming that most of you, if you're working with GenAI, you're probably using Python. I think, right? Yeah. Okay. Yeah, I see a couple of them. Okay, great. And thank you very much. Some of you also have entered in some comments too. Thank you. Thank you very much. And somebody says Golang. Okay. Yeah, cool. Yeah, that's great. Okay. Okay, awesome. Thank you. Thanks for your input. And then I have another question. Have you worked with any large language model or small language model? I'm just kind of curious too over here. I just also, again, wanted to get a sense of what types of model you have worked with. And some of you are DeepSeek, yes, and GPT, the OpenAI one, Gemini, Llama, Claude, kind of close contender of each other. There are also, actually, the option 9 is actually, I meant to say like others. I guess I forgot, sorry. So maybe that's why you're picking that, but I think you got it. So Copilot, okay, yeah. Well, Copilot is not really a model, right? If you're referring to Microsoft Copilot is their AI platform, right? And anyway, need to learn more about LLM. Good. Gemini is the most accessible one since it's free. Yes. Mind blown. Okay. We are all AI engineers. Transformers by Hugging Face. Awesome. Okay, cool. Thank you. So I see most of you are using OpenAI and GPT. A few of you doing DeepSeek. I mean, I would be a little bit cautious, right, with DeepSeek because they already said that all the data that you submitted there, if you're using the remote, the version that they hosted, the DeepSeek hosting it, then all of the private data will get stored onto their server. And as we all know, it's a country that's communist, so it's a little bit questionable. So, okay, but thank you. Thanks for your input and a lot of Gemini as well. And just the last one too. What are you looking to get out of this talk? So somebody wants to get an overview, and you want to do a code walkthrough, want to play around with it, and you want to see some GenAI app in action. Okay, great. A lot of you are ready to build something from scratch. That's wonderful. But although I have to admit, because this is in the workshop version, so you can take some of those exercises and play around with it too afterwards. Okay, awesome. That's great. Okay, great. A lot of you are ready to do stuff. Yeah, which is great because I ran this workshop, but they were not as big with a workshop group. A lot of folks were still new. So they're just, trying to learn about it rather than building something. So thank you. Thank you very much. Okay, that's awesome. And I think then that's all. And then if I do this, and if you then go to that, the screen, it gives you a result of all of the questions too. So thank you. Let me go back to this. So thanks for your input. Okay, so now let me then bear with me a little second, for just some introductory to GenAI, given the fact that a lot of us, or a few of us, are still new to this. You may be experienced, I'm sure you're experienced developers, but trying to get into something new too. So that's what I'm aiming at. But I want to kind of first say that, for AI, right, to me, I feel like all of us are already consumer. We are like eating the cake. But then, the thing is, though, all of us, I think, here are developers. So we are actually also the producers, too. We are developers, builders. We're building AI applications, and maybe some of you are training models as well. But I would imagine most of the usages would be into, application inferencing, which is using and understanding the LLMs and then developing applications using the model, too. That's what we're doing. So let me then also talk about some history too. I always find history is very helpful. And as such, right, generative AI only came out about a little over 2 years ago in November of 2022. And that was also after a lot of research too. There were a bunch of papers, and I'll go over it quickly. But the thing is too, is that it's interesting to see that the actual, a movement of all this artificial intelligence, machine learning started off back in the 20th century. It's pretty much, I like to point out 1950 when father of modern computing, Alan Turing, he wrote the paper, right, about can machines think? And that one is already kind of kicks off this whole movement. Not that he kicked it off, but I think the world, the whole of humanity is ready for something more, so to speak, more kind of not just like crunching numbers, right? We want to really experiment into an untapped area, which is artificial intelligence. And of course, many research is being done during that time. And just wanted to point out too, because I also worked at IBM before. When I first came to GITS, that was in 2019. At the time, I was working for IBM. And the thing is too, so it's kind of IBM also meant special for me too, even though I no longer work there. And so 1997 too, IBM developed Deep Blue, and that's actually a supervised training, specific like machine learning machine to actually play chess. And that beat Garry Kasparov, the chess king at that time. So that's kind of an early stage of all of the AI stuff, right? So therefore, like GenAI is not, the AI thing is actually already happening to kind of brewing up to this point. So if you're interested, I have also the link to this particular graph. I thought it's very clear to show the progression of all of the research that's being done until like 2000 in the 20th century. Okay, so after all, when we think about AI, it's really about automation. And I like to say that the fact is, even though everybody came out and said, oh, it's going to take over the world, but I'm sure if you're already working with it, you know that it is not ready. It's nowhere near. I mean, whatever it is doing is just wowing us. It's a bit of a hype, right? It can do one-shot kind of thing very well. But if you kind of tell it to do a flight reservation from beginning to the end, it can't do it. Unless, let's say now, we're talking about agents, right? Autonomous agents to do it. That's the next phase. But otherwise, too, all of the wowing things are more one-shot. You have to know exactly what you want. You have to tell it, right? All the prompt. That's why there's also this new field of prompt engineering, in which it's actually nothing to do with actual coding, but it's more like communication. How do you communicate with the machine and tell it to produce what you want it to produce? But I think I also questioned, too, when I first learned about this prompt engineering, I feel like, well, it's not really, artificial. It's not really intelligence. You have to tell it, then it's not true intelligence if you kind of think deeper. But it can figure things out, but then don't get me wrong. So, okay, so let me really then kind of set the stage straight. Basically, to kind of looking at AI, machine learning. So the left side is if I explain all these terminologies and see where they fit into each other. So AI is the all-encompassing terminology that basically mimics the intelligence of human beings or any living entities. And then it's more abstract. And then so if you drill down, then there's machine learning. And that involves the technique by which machines can learn based on its own and based on the data you give it. And they're also subdivided into supervised training, unsupervised training, and reinforcement learning. And as I'm sure a lot of you know, and this training model from data sets, all of these things. But by itself, too, it isn't quite enough, right? So you really have to go into deeper in order to make all of these magic to happen. And it really gets into how, like basically working on developing techniques to perform tasks that can mimic how the human brain works. And it's basically that's kind of inspired by our brain's own neural network. So that's the neural networks thing. Now, if you kind of go on the right side, I kind of put it in entering all the GenAI into the picture, all of the new terminologies. And as you can see too, AI is still there, encompassing, and there's machine learning. A large part of it also is the NLP, natural language processing too. That enables the generative AI. That's why it's able to understand your human language. And that's also one big difference is now with the AI, with GenAI, is that it's able to understand the command in the form of spoken languages. And that's all enabled by the techniques of NLP. So that's NLP is essentially an interdisciplinary study of languages and computer science. And then so as you can see, that forms the bulk of it. But if you go inside that machine learning, you look into it, then there's an NN is neural networks, and underneath is the deep learning side. And then also to LLM fits within the neural networks. And then GenAI is really the core part that kind of intersect between LLM, deep learning, and NLP. And as you can see, I actually also added in data. So basically, without data, there won't be any AI or ML. It wouldn't make any sense. So data is a very integral part of this whole AI, ML. Everything kind of ties in together. So just want to set the stage here. Okay, so now let's fascinating look at this GenAI era, right? So as we all know, we're already working with it, but kind of refresh our memory. It's basically a very disruptive field in AI. And again, because we're now able to ask the machine to do things and just speak to it like we talk to another human beings. Because if you think of it, right, before, when we do coding, we'll have to follow very strict rules. We have to say, even Java program, we need to give what are the parameters. We all know public void static main. And then you have your string, an array of strings. You have to kind of lay out all your parameters. What are the parameters and the value? But now, no need to do that, which is nice. And also, some of the things, if you think about it, there's no need to also convert. Is it a string? You need to deal with all the types thing, because everything is going to have is based on the prompts. It can figure a lot of things out. So certainly, some ways it's kind of time saver too, if you kind of think of it like that. So the thing also is that with generative AI versus predictive AI, which is like before GenAI, is that predictive AI also works with statistical model too. And it's already existing before GenAI came out, right? GenAI came out in November of 2022, not that long ago. But the thing is too, with predictive, is we're already doing business forecasts or weather forecasts. All of these forecasts are usually dealing with data. Whatever we're trying to predict has a time limit to it. You can do business weather forecasts for a certain time period. Whereas now with generative AI, now we're talking about a bit more timeless type of output. You're writing an essay, designing a dress, and composing a song. All these things doesn't have a time limit to it. So I'd say maybe that's a bit of a difference to it. Okay, so now just kind of a bit of a history too of this GenAI. Basically, these are some of the highlighting some of these papers, right? 2003, there was a feed-forward neural network, also from Google too. That's kind of the first one, and that laid the foundation for this ChatGPT movement. And then Apple also brings AI and NLP assistant to its first iPhone with Siri in 2011. And then 2013, actually, that's also a milestone because there was a paper on Word2Vec. And it was actually forms the foundation of vector database and how, you translate words into vector, and that forms the foundation of the vector data similarity searches too. And then 2017 was also a famous paper called the Transformer, and it's a simple network architecture that basically the punchline says attention is all you need, and that's where it came from. And that's also kind of all leading to the GenAI, the generative AI movement that we have today. And now, when we work with generative AI, we need these models. These are the essentially the runtime, especially now being most of us are maybe JVM people, then we look at, okay, JVM is like the runtime for the Java program, right? But it's like LLM is like the runtime for the generative AI type of processing. So these are just a handful of all of these models that's out there. But first, too, I started this diagram when I first spoke about this topic like a year ago, and it was OpenAI and the GPT 3.5 4.0, and then it also has the different modes, right? Stable diffusion with image to string, and image to text, text to image, and there are codecs like for coding, Whisper for audio, all of these. But now, as we can see, there are actually more than what I'm presenting in here too. But as you can see, these are just some of those models that are popular in here. And so I'd like to also point out BERT too. It's not really a generative model. It doesn't have the generative size. Strictly speaking, it's from Google, and it's a transformer architecture primarily. But it also qualifies as generative model. It forms the basis of the LLMs that we have today. So, okay. So one thing I want to point out in GenAI is that essentially, too, if you look at it, there are 6 main models of GenAI models. One is the text, and then, of course, it first came out with text-to-text. And then, of course, then there's image-to-text, and the Stable Diffusion was the first one from Stability AI. And it came out with Stable Diffusion, and then Dolly, and also the what's the other one? The Dolly and Mid-Journey. For example, those are kind of popular image-to-text, text-to-image model. There's also audio, video, and like, for example, OpenAI has Sora. That's a video-to-text, text-to-video, and 3D, and also like code such as GitHub Copilot uses Codex, this model. So there are different models. But the thing is, too, even a year ago, everybody was trying to support this multimodal capability. And now, just within not even a year, we're already seeing a lot of advances. Like Gemini is pretty much multimodal, all of the OpenAI models as well. But this area is still having a lot of research, too, because it's making this field even more usable. Can think of all the data as interchangeable. So again, we're kind of talking about GenAI is lowering the barrier to AI. Look at how easily accessible now even your children can do it, right? On your phone, you have Gemini running on Android, for example. So it's basically, these days, you don't need like a special data scientist or AI engineer to kind of run some AI model experiment for you. You can just use your phone and you go to ChatGPT, Claude, or all of these, Perplexity, for example. Maybe you're familiar. Are you using Perplexity? Anybody? One of you? Yeah, it's actually pretty cool. I think, because it uses not just LLM, but it also queries like real-time information too. So anyway, so definitely now with GenAI, this is moving towards everybody can use it easier. Although you do need to pay if you want to kind of do something more useful with it. So, okay, so let me kind of make sure I'm not talking like way too much. And okay, so then now kind of talking about GPT, the idea is basically it able to take simple prompts in natural human languages and then does all the pattern matching inside it. It's not really, strictly speaking, called a search, right? It's basically pattern matching within it too. And it answers questions based on the prompts. And it's able to figure out the context and build context more rich and enriching too. So we already know. So I'm not going to spend way too much time on this. And basically, these are just some history. It came out, GPT itself came out in 2018 from OpenAI, the papers that came out with GPT-1, and then very soon, within even just like 3-4 years, 2022 already came out with ChatGPT 3.5. Okay, so natural language processing, I'm already talking about it, so I'm not going to spend too much time now. It's basically, notice that generative AI, as much as it seems like it's powerful, but it's not very, in other words, it's non-deterministic, right? So we know that it's not, if you ask the model the same question 100 times, you will be getting different answers every time, slightly different. It's just because the nature of it is based on fuzzy logic. So because of that nature of LLMs and all of these, then it's not really reliable if we're going to use it for something that requires precision, as we all know. Or as of now, too, it's not very precise. Not only that, right, there's hallucination problems still there, even though it has improved quite a bit. So we just know it's just the nature of it. So as much, again, as much as it seems like kind of wowing us, but we have to be aware of this aspect of generative AI and LLMs too. But it's still doing a lot of things, don't get me wrong, but just that we need to understand it. So now then gets to large language models is what we developers work with every day in, day out. If we're writing any, code or interacting and making use of these large language models. So essentially typically, the one thing we also have to be aware of, LLMs is actually a very hungry thing, right? So it eats a lot of energy. So actually, too, is I just recently heard about somebody talking, it was actually in Chicago last week, that's right, an emerging technology summit where I was, and Google Cloud was there to talk to, and they were talking about how if you kind of do some searches, right, using LLM, basically maybe a simple search, some question, it can cost $4 US to do the search. But it's actually quite expensive if you think about it. And if you count all the energy that has to do all the work, it actually takes that much energy too. But the idea is that we want to kind of reduce it, so maybe become like 5 cents each. It should be like that rather than $4, right, to do a search. We don't usually think of it. We just want to get our results. But it is actually quite expensive. And it uses a lot of GPUs and all of these things behind the scenes too. And basically, too, the LLMs will have to deal with language processing and visual comprehension for computer vision, code generation, and also human-centered kind of engagement, too. You want it to be able to answer questions in the form of human kind of questions and analyze all the sentiments and deal with all the nuances, dealing with conversational stuff, too. So now, kind of looking at it a little further, this one I got from Google Cloud. I like it. It's pretty clear now. We are kind of seeing AI, machine learning, deep learning, and then inside is where LLM is the transformer, image generation. Everything is how they all fit together and making use of data science and NLP. So, okay, so I think that's the introductory. Although one more thing is that I already kind of mentioned too, LLM has its own limitations. You have to also know that LLM by itself doesn't have any memory. Also, it cannot preserve state, right? If you ask question, unless you write some code to preserve the state from one question to the other, or kind of build up the chain of thoughts and processing. Otherwise, too, if you ask one question and you turn around, you ask it another question, it can't remember. And also notice, right, the results are probabilistic. It's not deterministic either. And also, too, it's opaque, which means you cannot add any attributes to the answers, too. It might take your questions and then use it internally to build up it's basically to use it for training future stuff, too. But that's about it, and also very costly. And also is dealing with one-shot kind of usages, too. You ask it one question, and that's it. It doesn't remember things. Now, so the thing is to notice that in order for it to be really prime time, is basically we need to address issues such as scalability. You can do some fancy thing, no problem. But we all know some of you work for enterprise company or projects that are for big shops, right? And that deals with shopping season. You're going to have a lot of shops, orders coming in. You need to have something that handles all this scale. Not only that, reliability, recoverability, all these things the LLM doesn't deal with. I just deal with, you ask me a question, I answer you. You need something more serious, it just cannot do. What about workflows, right? So complex tasks, like for example, a flight reservation system, order entry, you need to have multiple steps, and they're also integrating with other systems. So those things are not there. So then that's why I feel there's no need to worry about our jobs going away. It won't be. Just because we still need to help, there's still a lot of human in the loop that will be needed in order to make it useful. But the thing is, we know what LLM is good for. It's just another tool. It's a powerful tool. We use it, plug it into our ecosystem and build things. I think that's what it's supposed to be. Even though we may think, we are listening to all the news, they are coming out and say, agents going to take over the world. I don't think it really is ready yet. Not only that, if you have tried using some of the, code assistant and even generating tests, right? Unit tests. For example, a couple months ago, somebody was showing a bedrock trying to generate unit tests. It came out not correct too. We were just doing factorial numbers and then realized, the test didn't come out correct. So which means we still as, developers, especially we need to tell our younger generations to don't get lazy. We still need to understand all the principles in programming, design, all of these things, and be able to be the one in control and kind of overlook it, making sure it is doing the right thing. So I see us as still being very valuable. We are still there to be in control. We need to remind ourselves of that, not like letting it take over. No, we don't. However, I think it is helping us. For example, things such as if you know what you're doing, maybe you're writing code, some of the boilerplate, some of the little bit of not little bit, but like algorithms that can be mind-boggling, maybe writing, I don't know, something like a complex data structure that it knows what to do. You can just tell it what to do. It probably can generate code for you very well. And you can then plug it into whatever you're working with. I think that, we can still make use of it in that way. And then at the same time too, we're developing agents. Yes, we can still kind of leverage on agents, but I think for agents, it will still take time for it to be truly autonomous, that we don't need to touch it. I don't think we'll ever reach that stage, to be truly telling the system and say, I want to fly, from Bangalore to Chicago, book me a ticket. It won't know. Yeah, you still need to get into it in the middle of it. So that's what I'm thinking. Okay. Now, and I probably don't need to be telling too much. You probably already know, how can I work with LLMs? There's like, for example, these are non-Java, like Langchain, Llama Index, or Semantic Kernel from Microsoft. These are all open source libraries, and Gemini API. Hugging Face, for example. Hugging Face is sort of like to me, it's like a GitHub, it's like code in GitHub you share and everything. But any kind of AI resources, data sets, model, you need to refine them. Hugging Face is where you can go to get those things. So, and then there are also Java-based, and a number of you are also Java developers, so wanting to share with you, I think Java is becoming stronger too. That's Langchain 4J, and also Quarkus has a tight integration with Langchain 4J, but Quarkus too also still uses the CDI, right? The context and dependency injection, that model too, and which is still very robust, don't get me wrong, but it's a little bit kind of older architecture. So Quarkus has it. And I think maybe Daniel, I don't know if he's also a speaker here from Red Hat. And I don't know if he's doing that, but me and him, we did a workshop together, at JFocus a couple months ago. So he talked about Quarkus. So if you're interested too, he's still around, you can catch him too. And then there's also Semantic Kernel, has a Java SDK. These are all open source from Microsoft. And then Spring AI also kind of came out to be better now than when it first came out. It's still quite young, the Spring AI, but you can certainly do stuff. And I have an example. If you want to use Ollama, for example, to run your model locally, I have actually an example in my GitHub repo if you want to take a look, and that's working with Spring AI, for example. So that's that. And then there's also a JLlama. That's actually a Llama, basically Java version for a Llama too. It's developed by Jake. I used to work with him at DataStax. He's the architect there. And then also there's another library called PgVector. It basically helps with vector database too. It speeds up quite a bit, and it's primarily right now for Apache Cassandra. And then there's also Llama 2 Java, which is a direct port from Llama C. Okay, so that's that. And then also this is just an example of Hello World in Langchain 4J. You just need to essentially make sure you have the model set up with the API key, and then be able to, this particular example is not doing anything. It just do a generate and essentially spit out Hello World in this case. But in reality, you want to also like submit your query to the model to ask your prompt to it too. So that type of stuff. So that's a really quick thing. And this one I won't talk much about. It's just basically about the people. I feel that we don't have to worry about our jobs. There will still be jobs who will be needed. So, okay, so just FYI, again, a quick set of examples will be in here. Again, I'll be sharing with you this slide deck afterwards too. So you don't have to be worried about it now. But essentially, I have a GitHub repo with my workshops if you want to reference that too. Okay, so now let me then get into the different aspects, right, or demystifying GenAI, prompt engineering. So prompt engineering, let me just quickly go through. So what it is basically you want to ask the LLM to perform a task in a way that will increase the likelihood of receiving a correct response. So therefore, it is very important to write effective prompts. So it's an iterative process too. And don't worry about writing the perfect prompt. And there are just some books too for you that you can also look up that can help you in that process. But essentially, too, it's just like communicating with anybody, too, with a person or whatever. You want to make sure your prompts provide very clear and specific instructions. For example, here we lay out a couple of points. You want to use delimiters to clearly separate different parts of the input, right? There are instructions, examples, requested response format, all of these things. And also, you want to give relevant details to perform the task, too. And also maybe request structured output if you want it in JSON or HTML, and also include any kind of conditions that should be verified before performing the task. And also you can provide examples to guide your bot to the LLM to answer it the way you want it to. So I have some examples in a little bit, but essentially, too, this particular use case is your company is a meal kit delivery service, and the CEO wants to create a chatbot so that users can ask for meal suggestions based on what they liked. So, and the starting prompt might be, right, in this case, you can say you are a helpful meal planner. Your job is to suggest meals based on the recipes and user input. If the user input is a question or request not related to generating a list of meals, then reply, sorry, I can't answer. I can only provide meal suggestions. So that's kind of an example. Some of the things you have to become quite explicit in telling it how to do certain things like that. So that's and so now we can update this prompt and give it even more details to it too. So with what it was, we can inject basically saying that follow the steps before recommending meals. So if the user requests a meal type you're not familiar with, then obtain information about the meal type before suggesting meals. And then secondly, obtain recipes from the master list that meet the user's requests and respond only with recipes included in the context. Do not add recipes from other sources. And then thirdly, you can say return a list of recipes selected in JSON with the following information delimited in triple backticks for each recipe. Then you basically lay out you want recipe name, and then basically that will be filled in by the LLM that comes back. Description, ingredients, directions, link, all of these things. So you do need to be, if you want to be really specific, you have to kind of give even the format, how you want the results back. And also specify conditions such as if no recipes are found or the number of recipes found doesn't satisfy the user's request, then reply, we're sorry, we don't have all the meals you requested, blah, 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 like that. So as you can see, it can become a full-time job. That's why I think there are actually job roles that are taking care of this too. So especially I think in an enterprise company, you probably will need somebody to handle this type of thing. So. Okay, so that's an example. And then these are also, I have a couple more examples too, but probably I won't get into all the details. Time goes by so fast, I realize. Okay, so if you want to take a look too of this, again, I'll be sharing this slide deck so you can take a look. I won't spend as much time then on prompt, but since I have other topics too. So basically too, the second thing is that you can also ask the model to think through the response too. So there's this chain of thought prompting too. So these are very useful if some tasks will require multiple steps, right? Or tasks requiring kind of complex reasoning too. Then you can include a chain or series of steps the LLM must complete before providing its answer. That's the idea. So like an example of a chain of thought prompt, So let's say if you don't kind of give it more help, like this particular example, you can say, when I was 4 years old, my partner was 3 times my age. And now I'm 20 years old. How old is my partner? And return the answer directly. Actually, the thing is, this is true too. We took this shot from asking. It comes back with 32. It's clearly wrong because, you can't just do like, okay, 4 times 3 and then plus 20. That's what it would think. So you have to ask it cleverly and say, so when I was 4 years old, my partner was 3 times my age, and now I'm 20 years old. How old is my partner? Let's think step by step. So then it would say, okay, when you were 4 years old, it was 3 times your age, and then they were 4 times 3, which is 12 years old. The age difference you have to calculate too between you and your partner is 12 minus 4, which is 8 years old. And now you are 20 years old. Your partner's age is, then you do the addition in there. So you see the difference too. Sometimes how you ask is extremely important when you're asking the LLM to do work for you. So, okay. So now, that was a very quick intro onto prompt. Now get into retrieval augmented generation, RAG, right? How many of you already have actually working with RAG? Maybe some of you. Yeah, quite a few of you. Thanks for responding. But just a really quick thing, right? RAG by itself is kind of conceptually is not too complicated. Essentially, just 2 models. One is the retrieval. The other is the generative side. So it's basically retrieval as such. It's basically help with gathering additional information that your LLM is not trained on. For example, you can have information from an external database, external data source, file system, can even be a message queue, any kind of input you want to grab from, right? Or some other kind of source of data. And basically, you want to have that be ingested and fed it into your LLM. Is essentially trying to then augment your prompt and then ask the LLM to answer question. And then the generative side is basically whatever LLM comes back with, the generative side will beautify the answer, will add more context to it, making it more enriched. That's the idea. So with that, then let's take a look too at this particular flow diagram. So essentially too, you can look at, step one in here. Again, this is still a simplified way of describing. It's basically user can submit a prompt to the RAG application. And it's basically RAG application is there, and then it will go and retrieves relevant context from the vector store and does some semantic searches, and it comes back. And then with that, we will then take whatever it comes back, and it's actually augment that prompt. And again, simplifying way to say that, you are enriching the prompt with more what you come back with, and then you then send it over to the LLM. And then it will come back with the relevant context to the LLM, and you get the response back. And then again, then that's when RAG application sends response back to the user. So that's kind of a simplified way of saying all of these. But as we all know, with RAG too, there are different types of RAG. You can, well, not like types, but like how granular you want to do the RAG, right? You can do just what is called like easy RAG. You don't really modify the data, so to speak. You can just take the prompt and send it over, whatever comes back, you take it. But there's also a naive RAG. That's actually, you do a bit of minimal processing to all of your input data and sends it over to the LLM. But then there are also that fancier, or not so fancier, more advanced way is if you need to chunk your data. Because sometimes you can be having, maybe your company, you have to, you're working with health data, and you have tons of PDFs file or any kind of documents, and they are huge. Basically it will kind of overfill. It can't take everything all at once. Then you need to split it up, chunking it. And also how you chunk it is also another topic of discussion. I think there's some speaker maybe I saw them doing like chunking as a one presentation, because the chunking becomes kind of an art form in some ways. You want to make sure too, when you chunk it, you don't want to the strict cutoff. You want to have one chunk, they have some overlapping, so then it can maintain the context between different chunks. For example, I'm just giving this as an example. So as you can see, there are also different aspects of doing RAGs, and how you kind of, deal with and massage all of the data is, again, a complex subject matter too. So, but again, this is kind of the basic idea of how this flow for RAG. Okay, so this one too, again, I'm just already talk about it just now, the role of the retrieval model, and then the role of the generative model would take, it works as like in tandem with the retrieval side, and then construct the final piece of the puzzle for you, and providing the contextual output that you can interact with. Okay, so demo. Actually, I'm not going to do demo. Let me quickly go into vector database and similarity search, because that's also part of the talk is supposed to be, but wanting to really quickly kind of talk about vector database. And how many of you are already working with vector database? We have a few folks. Yeah, maybe just a few. Okay, thank you. And but just to kind of give a quick example to you, not example, but just a quick talk, is basically vector database is a purpose-built database that serves up vector data type for complex machine learning purpose. And why? Okay, so essentially, vector database is basically what it stores are what is called vector embeddings. So you can look at data, like when it comes in, you'll need to convert it into vector data type. And these are essentially, they are arrays of floating point numbers, if you really kind of look into the details of these. So basically too, when you have data that comes in, you need to first convert them into embeddings. So the embeddings also, there are different specifications that you can rely on. So there are specifications. That's how it's specified, right? You have a string that comes in. How do you know what number for it to convert to? So that's what is specified by the spec that you use. And so when you go to use the data, when you go to query, then you need to use the same spec. And that just makes sense, right? Use the same spec for both storing and retrieving, querying too. So, and essentially too, what it uses is what is called like approximate nearest neighbor type of techniques too. And again, right, all of these, let me kind of go into the next slide, but okay, let me make it easier. So this is the mechanism, right? So what is a vector embedding? So it transforms all of the text into a vector called an embedding. So if you kind of look at this, for example, a two-dimensional kind of normalized vector. Now, in reality, this is going to be many dimensions. Now, what are dimensions? And I can give you examples, such as if you are storing a cat, right? So the way the machine learning is doing things is that for those who may not be new to this, you're not just storing, okay, a cat, what kind of cat like that, but it's more like you can have a cat. A cat is being categorized into a feline, is an animal, all of these kind of very granular way of identifying that object. And then not only that, they're even further divided into different, information about it. So those are kind of the dimension of the object that you're trying to store. So this is a very basic one about 2 dimension and how do you store them. And so within this space, I'm trying to explain is that the V1 is what you're trying to look for. It gets translated to an embedding. And what has been closest, within your search space is V2 and V3. V2 will get returned first. So it also depends on how you do the selection too. You can say, I wanted 95% proximity to it, or, however it's being ranked, right? It can search for all the stuff within your vicinity, but you want it like however percentages it is, and those will get returned to you according to how close you want the results to be to. So that's the idea. And then this particular example is indicating it can be a cat, and then you have dog and house. In this particular case, a dog will be returned because a dog is also an animal type, some kind of category that qualifies them to be closer together. So that's sort of like explaining approximate nearest neighbor kind of a technique, in the layman's term, so to speak, to kind of quickly let you know. But of course, what is enabling is being able to be done is the linear algebra that's behind the scenes too. And so now just wanting to kind of explain, right? A vector search is basically when you deal with many dimensions, a lot of data, then it also kind of gets into different layering too. So, and it's basically, as you can see, right? That's how it's able to handle data in bulk and also when they are very complex, having many dimensions to it too. Okay, so that's the vector search side. And then there are some examples of vector database, and these are some of the open source ones like Milvus or PgVector. PgVector, I think it becomes, I think I'd say is a bit more straightforward because it's a plugin to Postgres, right? So, and Milvus too, and Chroma, and Fast from Meta, and Quadrant. And Quadrant, my understanding, is actually quite fast too, and also somewhat easier to use. That I have to admit, I haven't used it, but people saying that you can just essentially plug it in and it works quite good. And then Weaviate too. And again, these are open source and there are also commercial ones too. For example, I work for DataStax. They also have their Astra database too. That's a vector database. And essentially, vector embeddings are not just used for searches. They can be used for clustering or recommendations, anomaly detection, diversity measurement, and classification as well. Okay, so let me see. I think I kind of don't have too much time in here. Okay, so this one, I won't get into all this stuff, but here too is just an example of vector data, how it's being used in a RAG type of application in this particular case. So as you can see, that's the database can be storing embeddings. And basically too, sometimes, right, if you want to like do LLM kind of processing, you need some ways of storing. And that's when you can consider using vector database to do it for you. Okay, so now I think the last part of this discussion is basically getting into agents and workflows. Actually, tomorrow I have a talk too, is later in the afternoon. I'm talking more into the agents part, but for now, it's just a really quick kind of thing to touch on the agents. But I think already there were folks talking about agents, I think, before, so I won't get into all the details, but at least give you some idea. So agents is basically authorized, to act for or in place of other. But just think of like when you, even like in non-computer thing, right? You can be doing insurance agent and, or travel agent, that's the idea. And not only that, I think if we're Java developers, JVM has agent too, that you can instrument your code, right? So it's not new. But I think the thing is, being able to leverage on agents is the nature of it is very specific, maybe doing some certain task. You can certainly be using agents to help you with that too. And essentially too, then there are also talks about agentic AI and multi-agentic, all of these things too. So agentic is basically here refers to someone or something that's capable of achieving outcomes independently. or possessing such ability means or power, having agency. So something that you can rely on to process for you on behalf of somebody else like that. So that's fundamental. But within the Gen AI context, right, agents are basically software entities that can orchestrate complex workflows too. And in that particular case, we're talking about multi-agentic. When you have complex systems, you can have agents that are responsible for different aspects of processing too. And it can also, some agents are specific tasks to coordinate the activities of multiple agents. And also, fundamentally, each agent is supposed to be specific to handle certain specific tasks too. That's the idea. And then you have each agent is responsible for something, but you have an overall overlooking kind of agent that ties together everything to orchestrate it. It's much like, to me, it's like an orchestra when you play, you go listen to music and basically there are different instruments playing and they need all be playing in sync, right? In the right tempo or different ways. So then the music comes out should be in sync, that's pleasant to the ear. So that's the idea. And okay, so now then there are multi-agentic system. It's basically for agents working in Gen AI. It's basically you want agents to become autonomous. Sometimes too, the decision making can fall onto the agents to make decision too. And in the multi-agentic systems, you have multiple autonomous agents working together, and they all specialize in different tasks. And then they actually even more kind of not fancier, but more like powerful would be if an agent doesn't have an answer, that agent ought to know which other agent will have the answer and should reach out to that agent for a specific answer. So that's the idea, but that's also harder to implement as well. So that's the idea. So in fundamental building blocks, right, within Java context, in Langchain 4J, there's this interface called AI services. It's basically a declarative interface to the desired API underneath, via, kind of think of it more like a proxy. So I just wanting to kind of point out within Java how you can do it. And also too, another topic that's also big within also the agentic subject matter is basically towards standardization is this model context protocol, MCP. You might have heard of as well, or some of you already working with. But to me, I think, MCP came out from Anthropic. Anthropic is the company that's kind of spin-off of OpenAI. So they came up with this protocol, open protocol that standardizes how applications are to provide context to LLMs. So, but to me too, when I look a bit closer, is that these protocols are a bit meant to be more with lower level. When you are writing tools, you want to have, for example, you want to design an agent that acts as a server, a service. You may want to follow this protocol so that, let's say you can have this agent is able to work with certain LLM. You can have another agent that works with yet another LLM, but you want to change things around. But because you're following a protocol, then it will make future changes easier. So that's why you want to consider using standardized protocol to do it too. So that's kind of some of the reason why you want to do that. Now, this is the newest thing, which is agent-to-agent protocol that came out from Google just a week or so ago, right, from the Google Next in the US. So A2A is from Google, and it's interesting too. And again, I'm just going to be quick, kind of point that out. That's also works for agent-to-agent kind of communication. But the nice thing about them is that even if you go to their documentation, they said they recommend MCP for tools and A2A for agents, and is what they say. And they feel they are complementary to MCP. So if you kind of go to their documentation, which I have listed in here, you can kind of take a look that they recommend, even A2A says, agentic applications need both A2A and MCP. And they recommend MCP for tools and A2A for agents. So that's pretty interesting. So this is just left for you to look into it if you're interested too. Okay, so I don't have as much time, but again, tomorrow I'll go deeper into some of these multi-agentic, the event-driven type that I like to recommend, how we can handle things. I'll use an example for a request for proposal type of scenario. You need to fill out forms. How do you use an agent to drive it, right? So that will be an example. So I won't have time today. But this too, I just wanted to quickly point out from Microsoft, they have their AutoGen. that's actually, they are showing this example of using LLM-based applications and how do you use agent to kind of handle different things and also plug in the human in the loop type of conversational things. So, okay, so agentic design patterns, I'll talk about it tomorrow. We don't have as much time now, but they're reflection, to-use, planning, and multi-agent collaboration. So I'll talk about those tomorrow. And but you will quickly, it's basically, there are a lot more Python type of ready libraries at this point. Microsoft has AutoGen or Crew AI is also a Python. And also LangGraph from Langchain, Langchain, that organization, and also an AutoGPT, more for MLOps too. From Java side, I haven't seen any actual multi-agentic library on that level, but they're mostly, I think they're for Spring AI, for example, is supporting MCP server too. Okay, so that's that. And then I'm almost done, but just some challenges. We just have to know that working with GenAI is not all fancy, right? There are hallucinations problems still there. There are ethical concerns. We need to put in guardrails, make sure it doesn't answer things, or give you answers that are illegal or kind of immoral, all these things. And also there are real-time data, but we can use RAG pattern to help augment, augment the generation. And then scalability issues, security concerns, sustainability issues with, high energy use, and also prompt injection too. That we also have to be careful. Just like SQL injection in GenAI context, there's also prompt. You can, it can be vulnerable too, right? Somebody can prompt something and plug in something illegal, for example, things like that. So, okay, so I think I'm kind of on time, but just wanted to share the resources. If you are interested in the slide deck, is here. I'll just leave this for a little bit. Okay. Okay. But I guess even if you miss, you can also, I think I'll be sharing it with the organization here too. So, and also some of these are different links too, if you're interested, the open source ranking information. Yeah. Okay. Oops. Sorry. How did I do that? Okay. Sorry, I clicked the wrong thing. Okay. And then here too, I also have my stream if you want to follow me there on Twitch TV. That's me. And also I have it on YouTube as well. If you want to follow me there. Yeah. Okay. Okay. All right. And then also, again, the lab info, if you want to practice some of these things or things, for example, how do you do Llama or Llama with Spring AI, things like that. I have that. Also vector database, a simple case. And meal planning, I also have it in Python as well, and a Quarkus example. And there's also some, this one, Hugging Face as a dataset viewer, I found it to be useful. If you're working with large data set too, you can use that. And also, I think that's it. And I think I'm just in time. And thank you very much. And if you have questions, feel free to come and answer me and connect on my Discord. Thank you. Thank you very much. Yeah.